Today let's talk about enthalpy, entropy, Gibbs free energy, and do a practice problem on their signs in order to get a spontaneous reaction. So enthalpy, as we know, if it's positive, it's endothermic, if it's negative, it's exothermic. But what does that have to do with disorder, which is entropy, a measure of disorder or chaos? So you can think of it as this. If it's a positive entropy, that means there is more chaos. So that is something more like a gas state, or when you have something condensed going to uncondensed, or when you have, for example, 2 moles of gas going to 3 moles of gas in a reaction. So those will all be in positive entropy because you're gaining chaos, gaining disorder in your system. Now there's also the idea that if you want a spontaneous reaction, the entropy, change in entropy, should be positive. So the universe should be gaining the entropy, while the system, being the inverse, will be losing entropy. So that would be a spontaneous reaction. And by the way, entropy is one of the only things on this list here that can be measured as an absolute, whereas the others you have to have a delta sign. So in an equilibrium reaction, the entropy will be 0. Just like in Gibbs free energy, at equilibrium, Gibbs is also 0, but their signs here are different. For a spontaneous reaction, the entropy has to be positive by gaining more disorder, but since G is a measure of spontaneity, G needs to be negative to be spontaneous. And just to review, all 3 of these values, H, S, and G, can be found by using this equation, which is basically Hess's law. And of course, there are specific formulas for each of them. And however, make sure that when you are calculating enthalpy using the bond energy instead of the products minus the reactants, it's going to be the reactants minus the products because of the bonds that are broken are minusing the bonds that are formed. Okay, now let's do the problem. What combination of signs do we need for a reaction to be spontaneous? Well, that means G has to be negative. And S, if it's spontaneous, it has to be positive by gaining disorder. And H, it would be preferred that H is negative, okay? Because these 2 are the bigger deciding factors on spontaneity, but usually we see that with a spontaneous reaction, it's usually always exothermic, right? Because the universe is gaining that chaos, so there is something that sounds like combustion going on, so that's exothermic. Okay, what about something that is totally unspontaneous? So by the way, spontaneous means a reaction can happen without additional energy input. So it just happens naturally. For example, in the textbook, they had an analogy like a lion chasing a zebra is also considered spontaneous because it's natural, whereas a non-spontaneous reaction, an analogy would be the satellite falling from Earth because it's not natural. Okay, so non-spontaneous, Gibbs is positive, entropy is negative, and this is usually positive. But it gets more complicated. Let's say if it's spontaneous at a high temperature. So it is spontaneous if you raise the temperature, and that means at room temperature then, okay, that means it is spontaneous at a higher temperature, so this can be both positive or negative. As for disorder, it means there is going to be more disorder, okay? And then for enthalpy, it's usually positive because you have to add more heat in order to drive the disorder. Okay, so what about spontaneous at a low temperature? So some reactions only happen at low temperatures, so that must mean this is exothermic, because endothermic is adding temperature, exothermic is you're removing the temperature. Okay, and disorder would have to be negative because you are being less disordered, more condensed, and that would be associated with low temperatures, more condensed. So for example, liquid to solid, that happens at a low temperature, and that is exothermic, yes, because you're cooling the system, and spontaneity can be positive or negative as well.